Good morning. I am Reggie, Associate Professor, Department of ECE. I am going to handle the topic line constant for zero dissipation, Unit line constant for zero dissipation. On completion of the course, students can able to understand how to write the dissipation less condition and a line of zero dissipation with the resistor, inductor and capacitor, how to find out R naught, propagation constant, velocity and wavelength. So in general, the line constant for a transmission line are Z naught is equal to square root of Z by Y, and Z is equal to R plus J omega L, Y is equal to G plus J omega C, and Z naught equal to square root of R plus J omega L by G plus J omega C, and gamma is equal to alpha plus J beta, and gamma equal to root ZY. This is the basic equation what we learned from the first unit. So gamma is equal to square root of R plus J omega L into G plus J omega C. When you are multiplying both these equation, you have to take the value of real part and imaginary part separately. Before that, you have to do the standard assumption for the line at high frequency. So when J omega L is greater than or equal to 0 R and J omega C is greater than R, so here you will get the initial condition R equal to 0 and G is equal to 0, and substitute the condition in Z naught and gamma. You will get the value of Z naught is equal to square root of R J omega L by J omega C. So Z naught equal to root of L by C. So from this value we can understand that the output impedance is mentioned in terms of the square root of inductance divided by capacitance. So normally if you consider the value of gamma, gamma is equal to square root of J omega L into J omega C. So if you multiply both the value, you will get J square minus omega square LC. So we can take out the value, you will get J square omega square LC, and finally you will get the value of gamma square root of minus omega square LC. So in that one you will get gamma equal to J omega root LC, alpha plus J beta. So alpha you know 0 and beta is equal to omega root LC. So this is the condition for a distortionless line. When you are equating the real part and imaginary part, you will get alpha value as 0 and beta value as omega square root LC. And you know that velocity of propagation is omega by beta, and velocity is equal to omega by omega root LC. Omega get cancelled, you will get velocity V is equal to 1 by root LC. And here lambda is equal to 2 pi by beta. Already we know the wavelength, the distance traveled in 2 pi radians, or distance between 2 pi radians will give you the normal velocity of the line. And if you substituted here lambda is equal to 2 pi by omega root LC, so here you will get the value of wavelength. These are all the line constant for dissipation line. So here we want to know the line constant for zero dissipation, the propagation constant of transmission line impedance and admittance and anti-inertia, how we are going to perform to get the output. If you substitute the value, you will get the maximum equation. Thank you.